Okay, in this video we're going to be reviewing the difference between array and element-wise operations in MATLAB. Okay, and so MATLAB, as we know, is a very, very powerful program, and one of its main strengths is the ease at which it allows you to work with matrices in terms of defining matrices and operating on matrices. Okay, and what you'll see is that the more and more you use MATLAB, you kind of start to think about your problems in terms of matrices, and so you try to think, I have this math problem. If I can put it into matrices, then MATLAB is going to have my back. They're going to be able to help me out a lot. Okay. And so as an example, as a simple example here, we have a linear system of equations, three unknowns. If you put this in matrix form, this is something that MATLAB is very, very well equipped to solve. And so, you can probably solve this matrix set of equations in, 3 lines of code. And so, if you think, matrices and MATLAB, then you're, on the right track on using MATLAB well. Okay. And so when we talk about array operations in MATLAB, what we're really talking about are kind of what I like to call traditional linear algebra vector-vector, matrix-vector, or matrix-matrix operations. Okay, so these follow kind of the traditional linear algebra rules for commutability and size compatibility. Okay, and so as an example for multiplication, in order for you to perform a matrix-matrix multiplication, the number of columns in the first vector must equal the number of rows in the second vector slash matrix. Okay. And so as an example down here, we have kind of a multiplication of a matrix and a vector. Here we have a matrix with 3 columns, and this vector is a column vector, and so it has 3 rows, and so these two are compatible because, the number of columns here, 3, number of rows here, 3, they're compatible, so we can perform this. Okay, and so to perform an array operation in MATLAB, you just have to use the mathematical symbol for the operator. Okay, so as an example here, the most common example is multiplication. And so when you perform matrix, you want to perform the multiplication of a and x in a matrix vector way, then you just do a times x, and this is the result that you get. Okay. All right, but another feature in MATLAB is that it allows you to do element by element operations. Okay, and so the difference here is that these are operations that are not applied on kind of the matrices as a whole in a traditional linear algebra sense, but they're applied kind of element by element. Okay, and so if you're going to perform element-wise operations on 2 matrices, they have to be the same size. And so one analogy that I think works really well is that you think of taking these 2 matrices and overlapping them on each other. Okay, and so you take this 1, 2, 3 and overlapping on that one, and then whichever entries are overlapping, that's what you're going to perform. Okay, and so in this case we have a multiplication, and so you can see here that the element by element, element-wise operation here, we do 9 times 1 is 9, 9 times 2 is 18, 9 times 3 is 27, 9 times 4 is 36, so on and so forth. Okay, and so if you want to use an element-wise operations, you have to precede the mathematical operator with a period. Okay, so the period is key here, and so perform this, we would do dot star instead of just star. Okay, and so here's the code for that. And so we have a all matrix of all 9s, and then 1 through 9 we have a numpad, and then we perform the element-wise operation, and this is what we get. Okay, so this is different than if we took these 2 matrices and multiplied them together without the dot, right? We'd get something very, very different, and so this is kind of an element-wise operation. And so this period, I call it a period modifier, and so it's a very powerful tool. You can use it for element-wise division and exponents as well. Okay, and so let's say that we have 2 matrices here, and we want to take the entries of one matrix and divide them by the corresponding entries in the other matrix, whichever is in the same slot. Then we do dot divide A4. And then if you want to take the exponent, and so you want to raise every entry in this matrix to the 3rd power, we do dot caret 3. Okay. And so you can also apply mathematical functions to matrices as well. So something like sine or cosine, right? And so if you do this, then the kind of what's implied is that you apply in an element-wise way. Okay, and so if we have this matrix here and we take the sign of this matrix, what we're doing is we're taking the sign of each entry, and what we get in return is just a matrix of that same size. Okay, so we take sine of 0, we get 0. Sine of pi over 2, we get 1. Sine of pi, this looks like it's a big number, but it's essentially 0, okay, because it's 10 to the minus 16. We take sine of 3 pi over 2, we get minus 1, okay? All right, so you're probably asking, we have these 2 ways to perform matrix operations. you probably want to ask, which one to use. And as is always the case in a lot of engineering and applied mathematics, it depends, okay? And so it really depends on, what you're trying to accomplish with your computation, right? And so, to kind of add more to that, I want you to remember that, you don't write MATLAB scripts just for the hell of it, right? And so we really write MATLAB scripts to kind of assist us in any kind of computations or visualization that's too much for humans to handle, okay? And so every engineering problem that you're going to come across is different, and they're going to require different mathematical techniques, different mathematical operations to perform, right? And so array-wise operations and element-wise operations are just two different tools for you to accomplish two different things, okay? And so as an example, you wouldn't consider a hammer better than a screwdriver or a screwdriver intrinsically better than a hammer. They just have different uses, right? So they're both useful tools. They're just used for different things, okay? And so think of this as kind of the same thing. So don't just kind of get locked into one or the other. And before I conclude, I just want to make a quick note about addition and subtraction. And so just because of the way addition and subtraction are defined, they're defined in an element-wise way anyway, and so you don't really have to put the period for these ones, right? And so if you want to do matrix addition or matrix subtraction, you just put plus or minus, and so there's no need for the period, okay? And in fact, MATLAB will give you an error if you do that.